So obviously there are numerous ways to implement, restrictions on the player movement so that they can't go outside the left and right edges of the grid and that they will stop when they hit the bottom of the grid. There are two that immediately jump out to me. We could use, collision boxes, trigger like invisible trigger boxes that are placed at the edges of the grid so that when the player tries to move left or right, they'll hit those and stop. Or we could just have, a hard-coded value in there. I think the collision boxes are probably slightly better because at least we can move those without having to change something in the blueprint. We can just move it around in the world. We could have the collision boxes be a component of the grid actor. That way we can configure them from the relevant blueprint without having a separate blueprint for just a collision box. I think that's probably what we'll do. But, either of those solutions do reveal a weakness in our design for the quad, which is that the quad is made up of 4 block BP actors, and the problem with that, or potential drawback of that, is when you're moving left and you want to test against the left hand border, so you make sure you can't move past into the black space here. You need to test for a movement from either the top left or bottom left block, so that you check those blocks positions and do like a ray trace to the left to make sure there's not a collision box there. And if you're moving right, you can't use the same blocks because it's the right hand blocks that are going to touch the border. So both functions just need to specifically use BL or BR in their checks, but you also need to check TL. So you need to check both blocks, I guess is what I'm saying. Top left, bottom left when you're moving left. You need to check top right, bottom right of your quad when you're moving right, because I guess the quad could split apart horizontally and the top half of it would move and the other half wouldn't if you weren't restricting it properly. And there may be a case where, actually I don't think it's possible for there to be a block suspended above, a chasm where only the top right or the bottom or the top left blocks would touch it. But for now, those complexities will probably reveal themselves with some pretty tricky bugs if we don't plan this out properly. But I think for now we'll just try it out and see what happens. This function is going to assume we can move left and just do it. But we could have a separate function that, checks to make sure you can move left. And then if that returns true, then we call this function. I don't know if we want to have the check and the, movement contained within the same function. That might be doing, 2 things at once in one function. We don't really want that for modularity purposes. So we'll probably break the checks into a separate function. I'm just realigning the execution flow. I also have this habit where I want to find the origin of this grid, which is, revealed by this thicker line here, these thicker horizontal and vertical lines, and move my the function name up into that corner. There's no reason to do that, but I like to do that. I don't know why. I feel like it improves my organization, but it's just a weird habit, I guess. A strange compulsion to keep it at the top left. Like this function did it automatically, but I guess when you collapse the nodes into a function, I guess it doesn't do that. But when you create a new function from scratch, it puts the function in this exact origin. So I like to keep it like that for some reason, but even I won't do that every time probably. So let's first add a collision box to every block, right? Because we need those. In Unreal, when you want to do a collision, you need to both actors, the self and the other, need to have overlap events checked. It says right here, I think in the tooltip, both components, this and the other, must have this enabled for overlap events to occur. So that's what we want. We want an overlap event. And we want to prevent overlaps from ever happening by doing a ray trace before we move. But let's not get too into the weeds on that. We do eventually need overlap boxes on the blocks because the blocks will have to collide with each other too. And that's when we really get into some fun complexity with this project, I think. Now let's add a collision. It could be a trigger, but I think collision is probably actually better. So we'll just add a box collider to our mesh here, and let's see. It's currently smaller than the block mesh, so we can scale it up. We probably do want it a little bit smaller than the block because it doesn't really need to be, we're not doing real like physics where the blocks are going to overlap, and we actually want the visual edges of the block to probably be able to touch each other without giving false positives on collision, because we do want the blocks to touch each other when they form connections. When we look one slot to the right or left when we're doing a movement, we don't want to run into a block that's actually one slot further to the right, like, if that doesn't make any sense, just believe me when I think we can probably get away with having a box collision that's actually smaller than the mesh. I think that's going to be fine. But if not, we'll get to that when we come to it. One thing I'm realizing now is I think this cube mesh just has a default size of like 100 units across or something, because I believe we spaced the grid alignment lines 100 from each other, and it just so happened to work out that the blocks are like perfectly matching up with that. So we'll keep that 100 value in mind when we do our ray traces. So let's go to the grid blueprint, and we need to add some box colliders to our construction. When we construct the actors components here, we need to add, after we do the visual construction of these columns, we need to actually add the colliders too. We could add them in here, but that would go against the names of these collapsed graphs, so I think we will make separate functions for that. Let's just go ahead and add component. Can we add a collision component? Add box collision. There we go. Perfect. We will add this to the, let's do the bottom first for no particular reason. No, let's do the left and right hand first for no particular reason. So let's do the left hand side. We again want to move up to here and then over, and then just have like a thin, but not infinitesimally thin, but the width of it doesn't really matter, but we want a block that goes up against this grid here so that when the player is here and tries to move their quad left, they'll run into that collision block and stop moving, or not do the movement at all. So let's go ahead and do that. We will reference the values we did here. We had it 10 along the Z, and these probably want to be thicker than that, but not too important. So when we add in the column collider here, we'll do 10, and we'll just do like 0.5. We'll see how that goes. Might be too thick, but. And the location needs to be up by num rows divided by 2. In fact, we can just take the logic that we painstakingly wrote over here to get the vertical offset. And the horizontal offset is going to be based on, it's just going to be a specific value, not based on anything, but it's going to be, I believe, 1/2. Or, it depends on our scale, I suppose, of how big we make our cube, but we can probably just do -1 horizontal offset. So just do -1 horizontal offset and feed that into our location here. So. My dog is yelping in her sleep right now. Hopefully that's not too loud. I don't know if you can hear it at all, but it's pretty funny. At some point I need to apologize for how bad my microphone probably sounds. It's just a cheap $10 video game headset that I got like 5 years ago, and I've rarely used it, but I know it doesn't sound stellar, and there's probably, you know, background hiss or whatever, but just using what I've got, so hopefully it's not dreadful. Let's go ahead and see what this looks like, if anything. Okay, so we've got a collision box here. It needs to be wider and taller, obviously. I forgot that I just talked about how the collision box is smaller than the cube, and yet I assumed I could use the same values. It actually does need to be taller than the grid so that we can't move left outside the grid at the top before we fall down, so that's fine. Let's go ahead and see what 1 and 1 looks like. Okay, it actually probably needs to be even thicker than that, so we'll just make it bigger than that. These values really aren't that important, I think. As long as it's not too big or too small, it should be fine. Just make it a little bit thicker. That might be too thick. No, that should be fine. So when our block is here and we look one entire grid length to the right, to the left, we'll hit this collision box for sure, I think. Let's just do 2.8. Okay. Now it's threatening to be too big. No, it's fine. It's definitely good. So now we just need another one on the other side and one on the bottom. So for the other side, it's going to have the same vertical offset, but the horizontal offset is just going to be num columns plus 1, maybe. Or plus 0, but we'll see. Okay, yeah, that seems good. And then along the bottom too. I guess I could do it all in one sequence, but I could also not. I'm just going to collapse nodes and call this add column collision boxes. And I'll just grab this. What a strange location. And finally, we'll add the bottom collision, finally. That's going to be half the number of columns across. So, similar logic to when we were adding the row columns, the row cubes. And then I think we just want one vertical offset downwards. So just as before, we just basically switched this. Now we have, times int times -1 so that it moves down. And we'll need to change these values. So, the ratio of 10 to 25, copy that for 16. So what is that? 16 times 2.5 is 40. So if I wanted this to be approximately the same, actually, that's not the right one to change at all. I want to change the x to 40. And then I'll just do these by sight, I guess. We'll see how big this needs to be. But didn't connect this. Good. It's a bit overkill in the width. I can shrink that down. Yeah, the reason I had it so overkill on the left and right sides was because I want to block the top two invisible rows here. But I don't need to do that at the bottom, so there's no reason for it to be that big. There's no harm in, I think, these colliders colliding with each other. But there's also no reason for them to be colliding with each other, so I can make this even smaller so that it just barely doesn't touch the other colliders. But it still needs to obviously block this column. Wow, perfect. 25 was the right value to begin with. That's hilarious. So now we have the colliders on the grid, which are not visible in game, obviously, so these will be hidden when we play. But now we need to make things happen with them, so now we need to change the values on these box colliders probably. Let's see if we can do that here. So let's go ahead and think what we need to do here. We could just overlap all dynamic. That might be fine. Yeah, we'll see how that goes. So now with the move blocks left, let's just focus on the left for now. We can adapt it to the other directions afterwards. But we need to make a function called check move left. Determine if the player's quad can move one space to the left. And it will return a boolean called like b can move. And so we need to get a reference to the, as I was saying earlier, we need the top left and bottom left blocks of the quad, and we check both for collisions, just to be sure that we can definitely move left with no obstructions in the way. Get quad BL and TL. And we should do a it has a different name, I think, in C++ versus Blueprint, but it's line trace for objects. So we do a, as the tooltip says, we do a line trace from a given position to an end position and see if there's any objects along that path, and return what we hit if we hit anything. So we want to start at the position of quad BL and later quad TL. and we want to move by, horizontal offset to the left. So that's what we're going to do. So in order to end at the proper position, you need to add the horizontal offset to our starting position. And obviously we need to do it as a vector, otherwise it's going to, add some weird magnitude. I don't know how that would work, adding a vector to a float. Obviously you can multiply a float and a vector. This actually needs to be inverted times integer. We're moving to the left, so we want to move one horizontal offset to the left from our starting position. And then we could, draw the traces for debugging purposes, but I think we can do that if we run into issues. But for now, we'll just hope it works. I'm trying to see which of these is more compact, if we have one of these or if we break this, neither one is really any better than the other. So down the road we may need to check to see if we hit another block actor. But I think, if we hit anything, if we overlapped anything, it would be the grid right now, because we want to check the cast to grid, and if the cast is successful, then the actor that we collided with was the grid. And because the grid's visual component, the cubes themselves, don't have colliders, this will only happen on the colliders on the edges. So if this cast was successful, then we will say we cannot move because he hit the edges. And if the cast failed, let's just see what happens here. What did I do wrong? Object types. So yeah, my mistake here is I need a list of object types to compare against when we are doing the ray trace. So I can right click on this pin and promote to local variable, just so we have something here, and call it object types. Doesn't really matter what we call it. And we'll set the default value to, I guess, world dynamic is what we're going to be going with. We need to double check what type the grid colliders are. They are set to world dynamic, so that's fine, then we're good. They probably could be static, since again the grid isn't going to be moving, but I don't think the performance is going to be that different. So now we have that issue corrected. And I check my logic here. So if what we collided with was unable to be casted to grid VP, so if it's either null, or I guess I think the problem here, why this feels so bad, is I need to do an is valid check here. This may be wasted overhead, but if it's not valid, which means what we the tooltip for the is valid Boolean return value says make sure it's non-null. This just says determines if an object is valid, which I assume that means non-null and not pending kill. So I think this returns the same result, but hopefully it does. So if the object is valid and it can be cast successfully to grid BP, then we can't move. Obviously we need to change this later to also include other blocks, but for now we'll just say this. Then we cannot move, otherwise we can move. So let's see what happens if we run this. Probably get some errors. So if we try moving down and to the left, and then we can move through it. So obviously there's nothing preventing this from happening because we're not actually calling the function. So what I need to do is use this return value. I'm not actually doing that. So when I call can check move left, then we need to use the return value. So if we can move, then we actually move. Otherwise, we don't do anything. You know, maybe play a sound like boom, 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 to let the player know that they're trying to move into something they can't move to. But I think for now we'll just do nothing. So if we try to move left, we can still move through the thing. So obviously we're not colliding when we thought we should be. So let's go ahead and print string here with the actor here, which would probably be null all the time. But I just want to see if it says anything when I... Okay, that's interesting. We're colliding with block BP every time we do that. So that's... Oh, here, now we're hitting grid BP. How strange. How very strange indeed. Hide this guy, and on our spawned grid, let's make these box colliders visible, so not hidden in game. So let's do the same for these two. So we can see them now, and they look obviously like they're big, right? And I'm crossing through it right now, and yet it's only when I get towards the center of it that it was reading the grid BP. But see, like I can do it up here, but for some reason, once I get to here, I start colliding with the object. That is highly unexpected. We are ignoring self, so why we are colliding with block BP is beyond me, because we should be starting. Let's go ahead and draw these for duration, and let's use, I guess red and green is fine. So let's see what happens now when we play the game, move left, then we'll pause and eject, go inside of our blocks here, and see if we can see the drawn lines here. It's colliding with, oh, this is no good at all. Now I know in C++ you can draw your ray traces as like arrows, so it's more immediately obvious which direction the ray trace is happening in. Maybe I can do that here. Or maybe not. Let's see. Well, this is fun. My first real debugging issue here in the project. So because the ray trace is returning block BP as the thing it collided with, either we're doing things in an incorrect order, so collisions are happening that we're not anticipating, or I am ray tracing in the wrong direction. Let's see, we're starting at quad BL, the bottom left quad, and what I want to do is move trace to the left. So horizontal offset is a positive value, which is to the right in our coordinate system, and we're adding a negative value here, so we're adding our location plus a vector points to the left. I mean, I want to say that's right, but without drawing things out on a piece of paper, I might be incorrect here. So what we could do instead of this is, you know, split everything, which will be a bit messy, but minus float and to make sure it's 100. So our current x location minus 100 is what we're ending at, and our y and z are going to stay the same. And we are ignoring self, so we won't collide with our own object. So we move left, we're still hitting block BP every time. So it does seem like the trace is happening from the proper location every time. It's starting at the center of bottom left and moving left by 1 unit, by 1 offset. And it's colliding with a block BP. Let's actually get the specific name of that block BP. Like I'm pretty sure, in the, oh, it is block BP without any numbers, so it's the like it is the bottom left one. That's block BP without any, numbers at the end. So it is colliding with itself. And the reason why, okay, wow, this is so a silly oversight of me, but the blueprint we're currently in is the player controller, not the block itself. So the actors to ignore array needs to include our actual self here. So self being the block we're starting at. So that's what needs to happen there. So that should solve the issue of hitting block BP every time. It should say null now or something, or nothing. And now we're hitting the grid from here. Oh, we're hitting the test grid. So, maybe I do have overlaps happening on the... Okay. The cubes that are getting added themselves do have overlaps apparently, which we don't want. So we can fix that by going to here. And just turning off all overlap events for the cubes spawned here and, of course, the cubes spawned here. And just no collision. We'll see if that solves that issue. Yeah, seems to be. And now we're correctly colliding with this. Okay, so what was happening before was because we were only doing a single object trace, we would stop the trace when we hit the first object we were looking for. The first object we collided with was what we got as the result of the ray trace. And since that was not the grid, it was ourselves, that's why we were able to move through things until we were literally inside of the collision box. Then we collided with the grid first. And now the things are working properly because we eliminated the issues, which was we were hitting the grid cubes themselves, stopping when we thought we weren't. And we're also hitting ourselves, the bottom left block, because we weren't including that as one of the objects to ignore. Because I mistakenly was thinking we were already ignoring ourselves when we were in fact ignoring the player controller, which is not even on the same y-axis value. So now things are working as expected on the left after some pretty obvious oversights. But that's the kind of thing that happens when you don't use the ray trace function very often, and when you haven't used collisions in a while. Collisions are not the easiest aspect of Unreal to get a grasp on, so hopefully, my struggling here was instructive in some way. Now that we have solved the issues with collision, we should revert some of these changes to the slightly neater looking vector notation. Looks a bit messy, but not that bad, I don't think. Get rid of this, obviously. And I think I'm going to go ahead and tweak this a little bit so that it's more going to get classier, and then do a branch with some Boolean operators here. So equal to grid VP. If I do like or Boolean here, so if it's equal to either block BP or grid BP, those are the things we want to collide with. They're basically the only types of vectors that are going to be in the game, but just in case you know there's like particle systems or something, might as well check. So we have if, we'll do one more thing, we'll do if is valid, and now again this is where a C++ conditional statement is going to look a lot more condensed and neater than this, but I don't know if there's like they call it short circuiting with conditionals in C and C++ when the left-hand statement is checked first, and if that's false and there's an and between that and the next statement, it'll just not even run the second statement. But so I don't know if the statements run in chronological order or left to right order, but if they do, then this will work fine, where we say if the object is valid and it is either one of these two things. We don't need to cast anymore, which is mainly why I wanted to do this. I don't want to cast for like no real reason. Seems wasteful. So if I still pretty gnarly, but I think it's better than before still. Yeah, you know what? I'm just gonna do this. So it is valid, just to ensure that it runs first, and also it'll get rid of that nasty cascading Boolean statements. So if the object is valid and it's one of these two types, then we stop moving and optionally do more things later, but for now we're just going to not move. So hopefully that makes sense. And I'll go ahead and do a sequence here so that I don't go really far to the right in my blueprint. I'm just going to repeat the same thing for the top left block instead of the bottom left block. So obviously I'm going to need to change this return nodes to do something different instead, like if both of these are true, then go ahead and return false immediately. But if both of them are false, if in any way it's false here, we need to continue on to the next part of the sequence, not quit immediately. So I suppose now I'll just add a third one here so there's not, so that the logic is the same in both these two steps. I'll just add a third one here, which is return can move. If it made it through both of those without returning false, then it will return true. I think I can, I'll leave it like that. It's fine. So that's move left. Check move left, rather. And now we can duplicate that and do a check move right and check move down. So I'll just duplicate that. Call it check move right. And just change quad BL to quad BR and TL to TR, and then change this from negative to positive, and that should be everything that we need to change. We'll go ahead and test that before we add the check move down. Remember, hold down the B key and left click to add a branch. So let's move right. I'll turn. Oh, I forgot to turn off the visual traces. But yeah, seems to be working properly. Actually, there's something interesting happening here. The visual trace isn't happening for the. Oh yeah, okay. So what's happening is once the bottom trace runs first, and then if that finds something that it collides with and returns false, then obviously it's not going to run the upper check, which is why we see both streaks when we move across like this, but then when we return can't move, then it obviously does one and stops. So that's why that's happening. That's why we're not seeing the two green lines entering the grid box right there, because it stops when it hits the first thing that returns false. So let's go ahead and remove those visual traces though from the function. I should have removed that before I duplicated it. And now I just need to do that for moving down into the bottom box. Okay, check move down should be very similar to the other functions, so we'll duplicate one more time. So now it's going to be BL and BR, because only the two bottom blocks are what we need to check. And we need to change this from X to Z. It would have been a little quicker to duplicate check move left, so we had the times -1, but that's fine. And this needs to be vertical offset. Again, this is the same value for now, but if this were ever changed to be not square-shaped grid slots, then at least all the logic will be there to accept different values for horizontal and vertical offset. So that's the offset change. Now we need to change this to, it's arbitrary whether you have BR or BL first, and since BR is already there, I guess I'll just do BL down here. I want to do the left first just because I tend to think moving from left to right, but you know, whatever. challenge our preconceived notions about what's important in life. So that should be fine. We're changing the Z, checking downwards in the Z axis. On BL and BR. Let's see if that works. So I need to go here and do the same thing I did before, where I add in check move down and use the return value to determine whether or not we actually move. And now if I try to move down, we can no longer move down any further, which is what we want. We want to be constrained to the grid, so that's very good. Now we have collision with the grid working, we have rotation working. We're well on our way to now making the actual gameplay work, which is once the player moves down through their own accord or through the timer ticking down, when they hit the bottom and then the collision returns don't move anymore down, then the block is placed and sort of deactivated. That is no longer the active quad. It is now just blocks that are placed on the field of play, and then the new quad will spawn in on top, and the player will take control of that quad and continue play until they make matches and stuff. So before we work on the matching logic, we should implement the drop functionality. That'll go hand in hand with the timer for automatically falling. So we're going to make it so if your player doesn't press anything, over time, the quad is going to drop one square at a time until it can no longer drop because there's something underneath it. So we'll go ahead and do that right now.